Hey everybody, this is Mr. McKee with Net 225. Today I'm going to be going over Packet Tracer 1.5.7. And just to let you guys know, if you guys are new to Netacad and Packet Tracer, the um, the numbering system, the 1.5.7, that corresponds to the page number. So chapter 1 or module 1, section 5, page 7 is pretty much how it's set up. All right. I see that two people already turned this in, so I guess some of you guys are getting learning it fairly quickly. All right. But mostly what I'll do on these packet tracers is I'll have the instruction sheet up, which is this Word document that's in Moodle, and I'll have a packet tracer. So I'm going down to the search box. I'm going to type in packet tracer. I did a video previously on how to install packet tracer, the current version. But if you want to check your version, go up to the file menu, click on help, click on about, and that shows you your version. If you notice, my version is the most recent version as of last night, so I should be good. All right. More than likely, when you log in, especially if you're opening up a .pkz file or packet tracer file, it's going to ask you for your Netacad login, so just know that. More than likely for all of us, it's going to be our user account for SEC, and then whatever password you specified or set up. All right, so I got this open. I'm going to do an arrow snap on this thing. So I'm going to have my, well, you know what? I usually like my instructions on the left and then the packet tracer on the right. All right, kind of like that. And then I can readjust it however I want to do it. Now, best practice I would say is if you have two monitors or if you have a laptop and you can hook a monitor up to it, just extend the screen on that laptop so you can put maybe your instructions on your laptop and your packet tracer, open that up on the second monitor, so you don't have to have everything situated. All right. So I'll just read through the objectives, instructions. I'll gloss over the actual answers because I want you guys obviously to be able to answer it. If it's a challenge question, it's optional. I may or may not get to it, but I've gone through here and I'm pretty good at letting you know what's graded and what's not graded, and if it's optional, it's optional. All right. The big thing is get your feet wet, get into the more you do it, pretty much like anything else, the more you do it, the more you get comfortable with it, and the easier it's going to be. So, especially since this is the first week of class, if you're brand new to college in general, you might think it's the end of the world, and Moodle is the most difficult thing to manage possible, and all this packet tracer stuff is going to be really hard. Just realize everybody else had the exact same thoughts, more than likely, as you're having right now, and they made it through, so you should be able to make it through. I know I did, but and I'm taking a class. I'm taking a HVAC class this semester, so I have that same feeling right now. All right, I'm taking that, and actually, I'm taking I took an Amazon Web Services course over the break, so I can get certified on Amazon Web Services. That was like that. So you're going to go through life, you know, learning new stuff, feeling like it's too hard to learn initially, and then you keep at it and you make your way through it, and then you start getting better and better at it. And once you start getting really good at it, that's when you get empowered and you start enjoying it and hopefully making a very good living at it. If it's true where people say that you need to do something 10,000 hours to get good at it, say a professional athlete has to work 10,000 hours, roughly, if you think 2,000 hours a year is the normal, 40 hours a week for 50 weeks, that would be 5 years. It would take you 5 years of full-time work to get really, really good at something, like expert level, engineer level. So start now, baby steps, and then work your way up. Once you get closer to more and more, involved and towards that 10,000 hour mark, you'll start learning stuff and making more, mind map connections to learn stuff even faster. All right. So, anyways, I don't want to get too much off on that tangent, but yeah. teaching yourself, learning how you learn best is really good to know. Anyways, I'll get off of that. But all right, so I have the instructions up. I'm going to do control and mouse wheel up to make this a little bit bigger. I just like to walk you guys through what I'm doing in case you want to do the same exact thing, or you're an instructor and you're instructing this stuff and you want to know best practices. All right, so starting out, and by the way, I don't think it mentions that you're actually using Packet Tracer to answer these questions, but apparently you're going to have to do that. But we'll find out. All right, because it references Packet Tracer. All right, so Packet Tracer network representation. I put in there anything in Reddit, so I added it. There's 14 questions to answer. All right, so objectives. The network model in this activity incorporates many of the technologies that you will master in your CCNA studies. It represents a simplified version of how a small to medium-sized business network might look. Feel free to explore the network on your own. When you're ready, proceed through the following steps and answer the questions. Note, it is not important that you understand everything you see and do in this activity. Feel free to explore the network on your own. If you wish to proceed more systematically, follow the steps below. Answer the questions to the best of your ability. All right, so this is just kind of like getting your feet wet. And if you're like military mindset, crawl, walk, run phase, this is definitely the crawl phase. All right. Slow is smooth, smooth is fast. If you know what that means, yeah, just take your time at it. All right, so instructions. Step 1, identify common components of a network as represented in Packet Tracer. The icon toolbar, and it's referring to down here in the bottom left. At the bottom left-hand corner has various categories of network components. You should see categories that correspond to intermediary devices, end devices, and media. And just a note, intermediary devices are like your switches and routers. They have two plugs, input, output, all right? Versus a end device is something that sits on the end of a network, like maybe a PC, a smartphone, a switch, I'm sorry, a server, all right? End device is on like it's like a net. Sometimes they call them a node. A node is on the end, and the media is what it runs on. Now, media can be invisible, like wireless, Wi-Fi signal, or LTE cell service, or it can be a physical media like wires or fiber optic cables. So the connections right down here, anything in black, it's actually talking about like the lightning bolt category with lightning bolt icon represents the network media supported by Packet Tracer, and hopefully you guys don't hear that beeping in the background, but people are emailing me nonstop. All right. There's also an end device category right here. All right. Looks like a PC, a server, and a IP phone. All right, end device category, so click on that. Two categories specific Packet Tracer, custom made devices, and multi-user connection. All right. So you got all this other stuff. And really, custom-made devices, we're not really going to use that in multi-user connection. Probably not going to use that. This is the first time I've taught CCNA version 7, so this is all going to be new to me too. But we'll get through it. I actually taught the second course and the third course of the 3 for the CCNA last semester. So I'm kind of like backwards this semester. All right, so list the intermediary device categories. So intermediary devices are right there. All right. When I mouse over this, it really doesn't tell me. It says network devices, but you got routers, switches, hubs if you're going to do old school, or have a repeater. A hub looks like a switch, but it only works on the physical layer. All right, you got wireless devices, which are like your hotspots and wireless routers and things like that. firewalls or security devices, and you have WAN emulation, which is represents a like the internet would be represented by a cloud, or if you had a private cloud, you could represent that with the cloud icon. All right. You also have like, if you want to set up like a DSL modem or a cable modem, they have those icons also. So this packet tracer thing does a whole bunch of stuff that's cool. All right, without entering into the internet cloud or intranet cloud, how many icons in the topology represent endpoint devices? And it's talking about that, not getting in here, but how many icons in the topology represent endpoint devices? All right, so endpoint devices are right there. All right. So a whole bunch of them. And just know down here, like if you take different courses, they'll have endpoint devices, which are your PCs, laptops, servers, IP phones, printers, anything that sits on is like a node position. All right. But then you also have this automation stuff. See how like it has cloud, internet cloud, or intranet cloud. I guess they're talking about that. This is all like the network devices, like IoT devices. But just count up these. That's fine. All right. Let's see. So without counting the two clouds, how many icons in the topology represent intermediary devices? So back to intermediary devices. And it says network devices, but yeah, that's intermediary devices. So you have there, you can count all these up, all your routers, switches. Just don't click on the cloud stuff. All right. How many end devices are not desktop computers? Well, end devices, that's a desktop. Like it doesn't show a tower, but it shows the monitor and the keyboard and mouse. I guess they consider that an all-in-one. All right. But how many are not desktop computers? All of these. You can count those up. And some of this stuff might not, like, it might be a little bit in the wrong spot, because like a network sniffer, that would have an input and output, unless that's just like a tap configuration. But anyways, don't worry about that too much. But yep, just count. We're just learning how to count on this one. All right. How many different types of media connections are used in this network topology? All right. If you hit lightning bolt, you can count up all these. All right. Explain the purposes of devices. This is step 2. In Packet Tracer, only the server -PT device can act as a server. Desktop or laptop PCs cannot act as a server. Based on your study so far, explain the client-server model. So basically, client-server model, I'm going to make a PC. Like you have a PC. We're not going to connect it directly, but we're going to do like, say if we do a switch. You don't need to do this, by the way, but you have a server. All right, so I'm going to do a copper. If you click on copper straight through, click fast Ethernet in this case. Don't worry about how this works, but click that again. Click here. Kind of like so. All right, and notice when I said in my last video, you got to wait for a convergence to happen for everybody to talk to one another. All right, a green triangle is good. A orange ball is not great, but it's working on it. All right, if it's red, it's not good. But see how it just turned green? That's converged. All right. It's sending out packets. It's learning. The switch is learning who's on the network. Maybe it's doing an ARP translation, things like that. Now, if I hit fast forward, all those green, the orange or I guess you can call them orange or amber balls, they turned green. So now it's fully converged. All right. So a client server model, you have a server traditionally that had a lot of processing power. Maybe it had a database on it or a web server running on it. The PC would want to get information and talk to the server so the server could do some kind of processing for it, maybe search a database or host a website. So PC would talk through a switch out to the internet to a server, and then the server would send its information back. Traditionally, the server was a lot more powerful, had more RAM, more storage, faster connection. It could run a lot more processes at the same time, and the PC would just kind of like talk to it. All right, that would be a client server model. All right. Nowadays, they have super strong PCs, and your PC can host its own website if it wanted to, and you know, PCs today were more powerful than servers were back in several years ago. But basically, this is the client server model setup. All right. There's always little differences and nuances. All right, so you could explain that for step 2A. List at least two functions of intermediary devices. All right, this is in the chapter, but like say a switch at the access level, like if it's going between two end devices, that gives you a physical connection in between end devices. A router would allow two separate networks to communicate to one another. Intermediary devices also like a Wi-Fi, a wireless access point that would give you a wireless connection to a network. Like a hub. A hub looks like a switch, but it's like old school and it doesn't do any kind of like level 2 switching or layer 2 switching. But a hub pretty much looks like a switch, but all it would do would it could amplify the signal if you're too far distance away from one PC to another PC or server. It would operate as a repeater. It would boost that signal and send it on. All right, that's another thing that it could do. List two criteria for choosing a network media type. Well, you need to know what's available. Like on a PC, like the PC I have, it has RJ45 Ethernet network adapters in it. So that and maybe a wireless like Wi-Fi card in there. Those are the only two things I could use. So what a PC has available in it, and also the distance. Like my Ethernet wired cable connection can go roughly 100 meters without having to be amplified by a switch or a hub or something like that. But fiber can go miles, kilometers or miles away. All right. And also, like around here, we're at agricultural area and manufacturing and things like that. If you're going to put it inside of a factory with a bunch of interference, you're going to want it shielded, things like that. But that's that I give you a bunch of criteria for that. All right, so compare and contrast LANs and WANs. Well, LAN is local area network, and a WAN is a wide area network. So I like to think of it as, like, say this is these three devices right here would be a local area network. All right. If I wanted to make a wide area network, usually a router would go in between there. All right. So say if I want to go, I'm just going to hook this to that. And notice you're going to have to turn the interfaces on a router on before it'll work. But like say that. And I'm going to get another router. And I'm going to hook the router together with I think it's that one. Well, actually, I do this. Do that. Do that. All right, so basically, this would be a local area network connected to a router, and the router connects you to another network. All right, another network could be sitting over here. All right, usually in a different geographical area. All right, so if we copied these three devices, put them on this side, this could be a local area network, and then this would be a separate local area network. Normally, a router would separate local area networks into a WAN. And I don't have this configured right, but if you look at Packet Tracer later on, anything that's connected together with a serial connection, which is like the Z, like a red Z, that's coming out of the serial connections on the back of a router, like this router right here. If I can zoom this thing in. Like this doesn't have the cards in it. I don't know if I don't think you can really see that card. That card, this is a card, and it'll let me put that in there if I turned it off. But that has a serial connection on it. All right, and then you also have gigabit like Ethernet connections too. But thinking old school way, which is still used somewhat, you have a serial connection on your WAN side of a router, and then on the LAN side, you'll have like a gigabit or a 10 gig connection from there out to your intermediary device, which would be a switch more likely out to your local area network. But that's just the difference. But yeah, thinking about Packet Tracer though, that's what I always think about. All right, if I see a red Z connected between devices, that's going to indicate a WAN, and a LAN has all more than likely all these copper straight through or crossover cables. And if you notice here, like if I go here and click and delete it, I don't want to delete all that, but if let's see, I'm going to put another router out here. Like say I didn't know how these connected together, I could go down to the lightning bolt, and if you click on automatically choose connection type, click that, and then drag over there, that automatically gives you the correct connection type, and it's saying that that's a copper straight through. I think I had a crossover. A crossover you'd use from switch to switch, but yeah, straight through you could use from router to switch. But now router to router, let's see if it works. Click there, click there. All right, see how that put a crossover? All right, so that just shows you how to kind of like cheat and do a hit the lightning bolt for automatically choose connection type. All right, so in Packet Tracer Network, how many WANs do you see? Is it? I guess it's. Maybe I'm doing this wrong. Hang on one second. Let's see. Okay, yeah. Sometimes I do this on the first packet tracer because it doesn't refer to the actual packet tracer number. But yeah, just like I was saying, if you go to, I'm going into course content. Like I clicked on here, clicked course content. It opened up this page, which is my course content for my intro to networks. If I was going to do packet tracer 1.5.7, that would be module 1, section 5, all right, and then page 7, so 157. If I click there, I've already clicked it, so it's showing up, but if I click it again, all right, those are your instructions, which we're looking at those right there, and then the actual packet tracer file, click there, it downloads that. All right, so if you click on that, let it open up. It's probably going to ask me for my username. Yep. Well, it didn't ask for my username. It might actually. Let's see. User profile. Now, what I want you guys to do though, make sure you put your just get in the habit of putting your name right there. All right, you don't have to put your email, but now it makes more sense. And what I'll do is just shut this down. I'm still in the mode of just going over Packet Tracer, but yeah. All right, so now what you'll see also, if you notice, this activity window is the same as this instruction sheet. All right, I know I've added in where I can put answers in there, but that's what you'll go by. If you see 1-1, that doesn't grade the Packet Tracer itself, so you really don't need to submit that Packet Tracer file. But let's take a look at this thing now. Now let me snap this thing in here. All right, so all that stuff was the same. Let's look. Now on here though, just like I did, that's a local area network, which is a home office connected together with there's a wireless router to a modem, then out to the internet. All right, then a central, like say a central campus or a central building, or this would probably be, well, it could be a building. All right, connected together over a intranet, so that's like an internal network in a business, and then out to a branch office. Notice intermediary devices, which all these routers. The internet is a series of routers connected together, so it is represented as a router connection, a little picture. All right, notice the Z patterns, like I was saying. All right. Also notice everything's converged. We're not doing any configurations, but if we saw orange circles or red circles, we know something's up. All right, so let's go through here. So now we can answer. That's why step 3B didn't make any sense to me. All right, so in the Packet Tracer network, how many WANs do you see? Well, in this case, if it said LANs, you know there would be 3 LANs, no problem, because they stick out like a sore thumb and they have a square box around them. But LANs, you could say, I haven't looked at the answer key, but each of these would be a LAN. They represent a geographically separated connection. So you could say really, I would say 4 or WANs. You could say 4. I would take 4. This is kind of like if this is an intranet for this business and that's their central LAN and their branch LAN, this would be incorporated all together as like a one WAN for everybody connected between these 2 points, but maybe 4 would be the best, I would say. All right, let's see. How many WANs do you see? So how many LANs do you see? Well, I know 3 right there. Sometimes it might get tricky though, because if you have a router sitting inside of your network, like these right here that's a router, that's a switch, that's a server. These things are actually layer 3 switches. So they do the work or some of the functionality of a switch and some of the functionality of a router. So you could kind of like say, depending on how these are set up, that could potentially be WANs inside of there. Don't think too much into that though. More than likely what they're looking for is everything in this geographical area connected to this router. All right, so 3 would be the right answer. All right, the internet in Packet Tracer network is overly simplified. It does not represent structure and form of the real internet. Briefly to describe the internet, so that's just an interconnected series of routers and computers. All right. What are some of the common ways a home user connects to the internet? You guys could say DSL, digital subscriber line, through the telephone company, cable modem through the cable provider. You might have a separate fiber company. You might have smartphone or hotspot via like 5G or 4G LTE connection, or satellite. We're in the country out here, so some people have satellite connections. I'm very blessed to have fiber, so yeah, that's good. And here we have gigabit download and upload, so it's like super fast at the campus. So we're very fortunate. All right, what are some common methods that businesses use to connect to the internet in your area? Well, we have CenturyLink, we have Star. That's more than likely going to be fiber. If some people still have old school like T1 lines, T3 lines, and they're keeping those going, they could potentially be connected that way. I would say more than likely they're connected through fiber connections to the ISP or internet service provider, then out to the internet. Yeah. So, challenge question: now that you have an opportunity to explore the network represented in this packet tracer activity, you may have picked up a few skills that you would like to try out. Or maybe you would like the opportunity to explore this network in more detail, realizing that most of what you see and experience in packet tracer is currently beyond your skill level. Here are some challenges you might want to attempt. Do not worry if you cannot do them all. You will be a packet tracer master user and network designer soon enough. Add an end device to a topology and connect it to one of the LANs with a media connection. I actually showed you that on my sample packet tracer topology I did earlier, so you can just do that too. All right. Just to let you know though, like if you add something, like add the device first and then connect media to that device to another device. But all right, so end devices are right here. Like say if I wanted to add a PC, I would click and get the crosshairs and put that wherever. And then with that there, and then you can click and drag it wherever you want it. And then you go down here to the lightning bolt. And then you click on the lightning bolt, and then you get a circle with slash through it. And then if you just, I'm not clicking on anything on my mouse right now, but you get the little, looks like an RJ45 end for Ethernet. That thing stays up there and it won't go away. Like if I'm going to click on the PC and then it tells me, okay, here's my options of connections on the backside of this thing. So the only thing I can connect right now is the fast Ethernet, which is like a 100 megabyte connection, or yeah, megabit connection. Click that and see how I get it's kind of like a live connected wire or cable. I could connect this now to somewhere which is an intermediary device on one of these LANs. All right. So I could potentially connect it to switch 3. I could connect it to, probably not up here. Well, this wireless router does have a couple Ethernet connections that are not used, but you can connect it to pretty much any of these intermediary devices. You probably want to connect it to a router. You want to connect it from a PC to a switch, and the switch will go through a router out to the outside of your LAN. So if I click switch 3, it would ask me, okay, where would you like to click? And notice Fast Ethernet 01. These start with 01. So Fast Ethernet 01 is already taken up, so it's not showing. All right. And Gigabit 01 is not showing either, because down here, and if I want to get out of this, hands off the mouse. If I hit escape, it gets rid of that like live connected cable. So if I look down here, switch 3. The reason two of the connections weren't showing up, well, you can see right. Well, when you mouse over it, come on. Mouse over it, see how it has link up? So those links are actually connected. So Fast Ethernet 01 is connected to the central server, and I'll mouse over it again. And if you look down to Gigabit Ethernet 01, that's up also, and that's connected to between switch 3 and R2. Now, I'm assuming that that's the way it is. To know for sure, if you mouse over the actual connection, and this looks a little weird because it's so close together, it's going to overlap it. But it's kind of like you got to play with it a little bit. All right, so see how it goes away? If you mouse over that, anywhere there's a green triangle or a amber or red ball, if you mouse over that thing, it'll tell you what it's connected to. And if you have each device to device connection is going to have two interfaces, one on each device. So when you mouse over something that's a little bit more spread out, like say this intranet, I want to mouse over that interface. See how it says the interface name? That's easier to see. And see when I mouse over that, it said this serial connection is that one, and this serial connection connected to the router is that one, serial 001. So that, I know that might be super confusing right now, but just know that you can figure that out. But also if you mouse over any device, it's going to tell you a bunch of stuff about it. So like I'm mousing over the central server, and that's telling me that it's Fast Ethernet port 0, and whatever IP address is assigned to that port. And also, it's not going to let me mouse over to it, but there's a MAC address that's assigned to that interface. Network adapter, in this case, it shows the MAC address. All right. So that's about it. I don't want to get too much into it. What else does this device need to send data to other end devices or to other end users? Can you provide that information? Is there a way to verify that you've correctly connected the device? And the best way is definitely to do a ping between the devices to see if they're connected. Add a new intermediary device to one of the networks and connect it to one of the LANs or WANs with a media connection. What else does this device need to serve as an intermediary to other devices in the network? I'll let you guys answer that since all this stuff's challenge questions. Open a new instance of Packet Tracer. Create a new network with at least 2 LANs. So what they're wanting you to do is close down this. And if I close this down, since I've made changes, I don't want to save these changes, so I'm not going to save changes. But anyways, open a new instance of Packet Tracer. Create a new network with at least 2 LANs connected by a WAN. Connect all the devices. Investigate the original Packet Tracer activity to see what else you might need to do to make your new network functional. Record your thoughts and save your Packet Tracer file. You may want to revisit your network later after you have mastered a few more skills. And just a hint, don't stress out when you connect. Whenever you connect switches to PCs or other end devices, they're automatically going to send traffic. But a router, on the other hand, it automatically does not send traffic because all the interfaces are turned off. All right, they're shut down. So whenever you connect to a router, you're going to get the red, I believe it's red triangles automatically. All right, but don't think your configuration's wrong. It's just not configured enough to let it connect. All right, so that'll be an issue. But that's it. That's all. I think that's it for that. So basically, just open up this Word document in Moodle, answer those questions. Each answer to the question should be in a different color, not black, not red, but like maybe a blue, making it easier for me to see and grade. So do that. There should be 14 questions to answer. Answer those, save it, save a copy for yourself somewhere where it's safe, and then upload that submission to Moodle. And that's it. Thanks for watching.